We get going on the next section in chapter 7. I want to ask if you guys had any questions about anything in 7.1 since we had 2 days of video lessons like in a row and then like 4 days of not mathing. So, did you guys have any questions in particular? Yeah.
Can you just like re-explain
Yeah, we can do one of the ones that involved like a substitution kind of factory one. Because we're going to be using this kind of stuff today. We're going to be continuing with our verifying and solving stuff. So doing one like this would probably be good. So let me find a good one where we kind of are going to substitute because something went a little gross. So, boop, 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 boop. I guess I didn't really do any that was super substituting. Let me find one that had some factoring then maybe. Okay, let me pull up the homework real quick. Trying to find one that does what I want it to do. Because I don't think we had tons that did substitution. It's just one of the options that we had. Let's do 24 from the homework. That's the secant to the fourth minus secant squared. So we'll look at 24 on homework 7.1. And we're asked to verify. There we go. Oh, it's going to freak out on us. There we go. All right. So I believe I said this was 24. I think. I might be wrong on the number now. I didn't write the page number down. But it's the secant to the fourth of u minus secant squared of u, and we want to verify if that's the same thing as tangent squared of u plus tangent to the fourth of u. All right, so this is from the homework. I want to say it's 24, but I can't pull it back up without changing the thing. Okay, so this is straight up from the homework. And what we have to do is we have to figure out which side we're going to play with. So secant, that's 1 over cosine. So that's not too bad. Tangent is both sines and cosines. So let's play with that so that we can make it be just cosines. So the whole goal is to take my tangents and make them be just cosines because secant is just cosines. So what we're going to do is I'm going to take all the things on the right-hand side. We're going to play with the right-hand side. And I'm going to switch these to be sines and cosines. So tangent squared, that's the same thing as sine squared over cosine squared. And tangent to the fourth, the same thing as sine to the fourth over cosine to the fourth. I'm just switching them into sines and cosines. Then since I have fractions, that have different denominators. Let us simplify that. So we switched it into sine and cosine. That was our step. And now we are going to get to common denominators. I need to be able to add them together. So what do I need to multiply this left-hand fraction by to get to common denominators? Yeah, cosine squared. Because we're going to wind up with a denominator of cosine to the fourth. So our numerator is going to be this piece times cosine squared. So we're going to have sine squared u cosine squared u plus sine to the fourth of u. And this is starting to look gross. But then we're going to look close in here. I'm going to change this viewpoint just so you can actually see what I'm writing because these are starting to get small. What can I do in this numerator to kind of help simplify stuff? What do they have? Is there something we can do up there? Yeah, I see that there's sine squareds in both of these. So what I can do is I can factor that out, and we'll see if that will actually help us with something. Oh, not the pink. So I'm going to keep this over my cosine to the fourth. And that's going to give me sine squared of u. Inside here we have cosine squared of u plus sine squared of u, because I'm factoring out sine squared. So from here to here, we factored. So that's just giving you a step over here. This is an equal sign, not some weird symbol. Then what can we do? What do we see in here? Yeah, this is a Pythagorean identity. Cosine squared plus sine squared plus cosine squared, that's just 1. So that's a Pythagorean identity, so we're going to wind up with sine squared times 1. So this is going to be simplifying down to sine squared times 1 over cosine to the fourth. Which is definitely simpler. Like we're definitely getting simplified. We've got this down to just one fraction. But remember my goal. I need to get this to just be secant, which is just cosines. So I need this sine to switch into something that's cosine-y. How can I switch? This was Pythagorean identity. What can I do to switch something sine-y into something cosine-y? Yeah, we can use that Pythagorean identity again and switch my sine squared into 1 minus cosine squared. This was another Pythagorean ID. Just so I'm giving you step-by-steps. You don't have to write these step-by-steps on the side. It's just so that you guys can see that if you're looking at this later. So now I have everything in terms of cosines. And we see that it's been separated into two pieces here. So I'm always kind of looking back at this. This is my target. This is where I want to head. If I don't see myself headed this direction, we can stop and go a different direction. So this has two separate pieces, and I see two pieces in my numerator. So I'm going to split these apart into separate fractions so that we can simplify. So that we're going to have 1 over cosine to the 4th of u minus cosine squared u over cosine to the 4th of u. And this is split the fraction. And then we're actually almost done. Because all we need to do is look at this right-hand piece and go, oh, I can simplify that. We have 1 over cosine to the 4th of u, and what is this going to simplify down to? Super close. 1 over cosine squared. So we have 1 over cosine to the 4th minus 1 over cosine squared, which is the exact same thing as secant to the 4th and secant squared, which is exactly what we were originally looking for. Okay, so it's just a matter of kind of using one side as a guide to try and get us there. And substituting switching pieces around, using those Pythagorean identities. We're going to be using those a bunch of times. And we're going to be using things, and we're going to continue working with these over the forever. Just an FYI. But especially today, we're going to be continuing to work with verifying and simplifying, because what we're going to do is we're going to start solving. Solving for, in this case, it would be u, solving for y, solving for theta, solving for x, solving for all kinds of stuff. Okay? So, 7-1 was what we did last week with all this verifying stuff. The answer key is up for 7-1. I did manage to get that done and up and posted before you guys have to turn it in. So if you want to look through that, make sure you're headed the right direction. It's up. And we're going to go ahead and scooch on to 7-2. So this is section 7.2. I usually try and write it up there. And we're going to start solving. So we're going to be given problems that say solve. And what that means is we are going to use our solving techniques, our simplifying, our verifying, those same techniques we had to isolate the trig function. And then we're going to be using our unit circle to find solutions. We told you it was important for you to memorize the unit circle. This is 100% part of the reason why. We're going to be using it to find our solutions for this. And since these are periodic functions, meaning they're going around and around and around the circle, because we have all those, oh my gosh, my brain just 100% forgot the word. The angles where they end on the same side, the same terminal side, coterminal, there we go. Those same coterminal angles, it goes around and around. We're going to wind up with repetitive solutions. It's going to happen every time it goes around. So when we're looking at sine and cosine, we're going to have to take whatever our answer is, and we're going to add 2 pi n to it, just like we did when we were looking at those asymptotes, and we would add pi n or 2 pi n because it happened every time it reoccurred. When we're looking at answers or solutions for sine and cosine, we're going to add 2 pi n because that is the period of sine and cosine. If we're only looking at tangent, think about how tangent has a smaller period. we're only going to add pi n so that all those coterminals are included in our solutions. And I'll show you what this looks like, I promise. When we write things out, it always kind of feels a little bit like Greek until we get into it and start working with it, or at least that's how it is for me. Yeah, let me write you this. Okay. I'm going to give you guys a little bit more time to write. I still see a bunch of people writing, that's okay. All right, I'm starting to see the writing slow down. Give me like 5 more seconds. Okay. So we're going to get problems like this, where it says solve the following equation and find all possible solutions. So we get something like 1 minus 2 cosine of x equals 0. So what we want to do first things first is I want to get my cosine of x all by itself. I need to isolate my trig function. No numbers with it, just I want cosine of x equals, or something equals cosine of x. So what can I do to isolate my trig function? Couple of different options on how to go about it. Absolutely fine. You can absolutely subtract 1. That's going to give me minus 2 cosine of x equals negative 1. Divide by negative 2. If I divide by negative 2 on this side, divide by negative 2 on this side, we get the cosine of x equals negative 1 divided by negative 2 is positive 1/2. And then I want you to think about your unit circle. We've got our trig function isolated. Cosine of x, 1/2. So if you need to, look back at your unit circle when we filled it in like a month ago. Or I can give you another one if you want to fill it in real quick. So remember, cosine is our x term in the ordered pair. So what x values, what angles have a cosine of 1/2? Not 45. The 60-degree one does. I'm going to put it in radians just because it's what we're calling pi over 3. And what else? 2 pi over 3 does not have a cosine of positive 1/2. That has negative 1/2. It's 300 degrees. Yeah, I'm going to put it in radians again, so that's our 5 pi over 3. We can absolutely do them in, since you guys were pulling degrees anyway, I'll do them in purple over here. I'll do the degrees as well, but since we wrote it in pi, 60 and x equals 300. Okay, so I'm doing this as 2 separate thoughts. I'm just kind of making it up as we go right now. Not really. For the most part, we're going to do radians. Occasionally we'll do degrees, but more often than not, we will do radians. Because it doesn't just happen at pi over 3. Because it happens, if we think about our unit circle, this is happening at our pi over 3. And then again, it'll happen when we come all the way around the circle and hit it again at pi over 3, or at 7 pi over 3, and do it again when it comes around again. It's happening every single time it comes around the circle here. So it's happening at pi over 3, and then again every full rotation of the circle. So, and every 2 pi n. Same thing with our 5 pi over 3. That would be this guy down here. It's happening at 5 pi over 3, and then again on our, what is that, 11 pi over 3? And then again as it comes around again and again and again. So it also needs to get our plus, wrong color, 2 pi n. So if you were to pull this up with degrees, so I know several of us thought the degrees first, and that is 100% okay if that's where your brain goes. Make sure you're not adding 2 pi n, but you are accounting for the coterminals by adding 360 n. Okay, so if you prefer to go in degrees, that is fine. Make sure you know how to work with radians. I do tend to write it in radians because we're going to use those a lot more throughout the course of the semester, but degrees is okay. It's not wrong. You just got to make sure when we're writing out to include all possible angles, we include those coterminals. Okay, again, I tend to write it in radians. And if you look at my answer keys, unless they've given me something specific about degrees, I almost exclusively write it in radians. But it's not wrong to put degrees. They mean the same thing. So the difference between yes and see and we. It's just slightly different, means the same dang thing. Okay. So this is how we're starting out with these solving things. So let's do another one. So here's our next one. We've got sine of x plus 1 equals the opposite of the sine of x. So what should we do first? Our goal needs to be to isolate our trig function. So I need to get my signs together. Because I have 2 signs of x here, one on each side of the equal sign. What can we do to get our signs together? Add a sine of x. I've got a minus sine x over here, so let's add sine of x. Plus sine of x. So that's going to give me 2 sines of x over here plus 1 equals 0. Then what? Minus 1 from both sides. It's going to give me that 2 sine of x equals 1. Negative 1, correct? Totally just making sure we're paying attention. So what does sine of x equal? Negative 1/2. So what values of x have a sine of negative 1/2? Now 3 pi over 4. 7 pi over 6 does have a sine of a negative 1/2. And 11 pi over 6. But then we need to include all of those coterminals. So we come to both of these, and we're going to add 2 pi n. Because it happens no matter what angle it is. If I was to give us 43 pi over 6, that would still count because it's coterminal with 7 pi over 6. It's just that I went 6 times around the circle beforehand. Okay. We're going to keep going. They're going to get slightly and slightly more each time. Because now we have a tangent squared. And you have a couple of options when looking at this one. We have tangent squared of theta minus 3 equals 0. And I can see 2 different routes that are equally easy through it, and at least one that's obnoxiously hard. So what's your instinct when we see something like this? To try and figure out what tangent theta equals. Add 3. That is a fine option. We can make this be tangent squared theta equals 3. But I don't want to know what tangent squared theta is. I want to know what tangent theta is. So what can we do? Square root it. The tangent of theta equals plus or minus square root of 3. Remember, with tangent of theta, we only need to look at the top half of the circle. Because tangent has that repetitive period that's shorter. So let's look at our unit circle. See if we can figure out where does tangent equal the square root of 3. Positive or negative. We don't care which one. We need to look at our unit circle. Remember that tangent, let's see, over here, is sine over cosine. So if we want to have square root of 3 on the top, we need to know when our sines have the square root of 3 on the top. So where do we have sines with the square root of 3 on the top? 2 pi over 3. If we think about 2 pi over 3, that's square root of 3 over 2 over negative 1/2. Those halves cancel out, and we have just our negative square root of 3. We had plus or minus square root of 3, so 2 pi over 3 is absolutely valid. Where else do we have a theta pi over 3? On tangent, and when we get to a cotangent, we're only going to look at quadrants 1 and 2, the top half. Because tangent has a period length of 1 pi, we don't have to look at both pi's. So to get our coterminals, we just have to add pi n, because tangent repeats a lot faster than any of the other ones. So for both of these, we're adding pi n to get those coterminal angles. So our answers are going to look really weird because these are the 2 answers we get. We're getting 2 solutions. Technically, we're getting infinite solutions, but you write it as 2 solutions. Okay. So sometimes we're all nice and we give you with just one trig function in it. Sometimes we get a little mean because it's Precal, and that's life. So here's our next one. We've got secant x, cosecant x minus cosecant. And what we're going to do is we're going to use our simplifying stuff to try and get this as simplified as possible. So I want to get all my trig functions on the same side of my equal sign. So my first goal is to get my trig functions together, which means my first step is going to be subtract. I'm going to subtract my cosecant x to get it to come over here. So we're going to have secant x cosecant x minus cosecant x equals 0. Say it again. Since it's secant times cosecant, it's not going to cancel out. But what can we do instead? It was a thought. It was about 4 thoughts, and I think you were headed close to the right direction, but we just weren't finding the word. Super duper close with the distribute, but I don't have parentheses here, but we can factor. We can undistribute it. Because I have cosecant in both terms. So we have cosecant x. If I factor that out of both terms, we have secant x minus 1 equals 0. Now think of it like it was a quadratic. I have 2 pieces multiplied against each other. This is going to happen either when cosecant x equals 0, or it's going to happen when secant x minus 1 equals 0. So if we get to terms being multiplied while it's in isolation, so when I have only one trig function, split them. Do it like a quadratic. So remembering that cosecant is the same thing as 1 over sine. When are we going to have 1 over sine equaling 0? What do we think? Well, if it's 0, I can see why we think that, because sine of 0 is 0, right? What happens when we divide by 0? Undefined. So do we have any place that this happens? No, there's no solution for this part. It doesn't happen. We don't have any time when cosecant of x equals 0. So then let's look at our right-hand piece, see if we have a solution on the right-hand piece. I need to isolate my trig function again, so we're going to add 1 to both sides. So we have secant x equals 1. Remembering that secant is 1 over cosine of x. When does 1 over cosine of x equal 1? When cosine of x equals 1, which happens when x equals, what's our angle? When does cosine equal 1? Remember, cosine is your x term. When my x is 0. But wait a second, we just talked about x equaling 0 being a problem over here. It's not possible to have it work on one side and not work on the other. Since x equals 0 is not in the domain of cosecant, this whole function is going to wind up with a no solution. It technically works for the secant portion only when x equals 0, but the cosecant throws a wrench in it. So if you wind up with pieces that have no solution, make sure you're double checking that they don't throw your whole solution set off. We wind up with no solution for this whole function. No solution is a fine answer. But I'm not going to end us with that one at the end of the day. So we have one more, but it's not a super long one. Okay? But I'm not going to end us with a no solution. That's just mean. Sometimes we're going to get funny numbers, though, too. Last one. This is the last one for the day. So we have 7 cosecant of x plus 2 square root of 2 equals 9 cosecant of x. What's your instinct? Aside from cry. Subtract the 7 cosecant of x. Get your cosecants together. Minus 7 cosecant of x from both sides. Just because it's got a number in front doesn't mean we're doing anything different with it. We get a little scared when these trig functions start getting number friends. But it's okay. So we have 2 square root of 2 equals 2 cosecant of x. Then what? Divide by 2. I heard it. Divide by 2. So we want to know when cosecant of x equals square root of 2. Remember that cosecant is 1 over sine of x. So we need this to be positive square root of 2. And we get to look at the whole circle again because we're dealing with just sine. Where are we going to have this? Pi over 4. Remember that sign is only square root of 2 over 2 because we rationalized. If we have it as the reciprocal and we re-rationalize, it's just going to be the square root of 2. Where else do we have positive square root of 2? 3 pi over 4. Exactly right. So these are our two unit circle answers. To get our coterminals, we add 2 pi n. We add 2 pi n. So once we find them on the unit circle, you add your 2 pi n. Okay? So, I do have in the file folder for, I'll put it back up, yep. In the little thing above the turn-in bin is the schedule for the rest of the chapter. I didn't have it for you last week. It is there now. It's got all the homework assignments, all the quiz dates, that kind of thing. So it's it's pink paper. Grab that if you like to have it. Otherwise, I will post the things up here like I do every day. We are going to have a quiz this Thursday. Over 7-1, the verifying stuff. Okay? I do already have the answer key for 7-1 up on the Canvas page.